4.3, graph using intercepts. The x-intercept, you'll often see me write it x-int of a graph is the x-coordinate of a point where the line crosses the x-axis To find this, we set y equal to 0 and solve for x. And once we get into this, I'm going to teach you a cover-up method that makes it even easier. The y-intercept, and again, you'll see me write this as y-int a lot, of a graph is the y-coordinate of a point where the line crosses the y-axis. So on the other one, we set y equal to 0 and solve for x. On this one, we're going to set x equal to 0 and solve for y. So some of these problems are going to just ask us to find the intercepts, and then some of them are going to tell us to graph, and we're going to be using the intercept method to graph these ones. All right. Find the x and y intercept of the graph of the equation. So these ones we are not graphing, we're just finding the intercepts. So number 4, we have 5x minus y equals 35. So to find the x-intercept, I set y equal to 0 and I solve. So we can either do this where we're actually physically plugging in a 0 for y, which would be that I would do 5x minus 0 equals 35. So then obviously that's nothing. I divide by 5. So x is equal to 7. So that's my x-intercept there. The y-intercept, I set x equal to 0 and solve for y. So I would have 5 times 0 minus y equals 35. So this goes away. I can then divide by -1. So y equals -35. And that's my y-intercept. Now the other way I can do this, I'll do it in the next problem so that we can see it. That works the same way without me having to show all of this out, is to do something like this. So I've got -3x plus 9y equals -18. So we have what we call the cover-up method that I like to use for this, and it makes it fast and easy. So when I'm setting y equal to 0, what's happening to that entire piece? This whole piece right here. It's going away, right? It goes to 0, it goes away. So what I can do is I can literally cover it up with my finger, now that I've selected the whole thing. And then I can just say -3x equals 18. -18 divided by -3 is equal to what?
6.
6, so I can just say x equals 6. Then I can do the same thing with the y value. We set x equal to 0, so I cover up the x. So I have 9y equals negative 18, so what is y equal to? Negative 2. So, very quickly, you're done just by doing the cover-up method. Now, if you need to write out the work, that's fine. You absolutely can. It's up to you, but a lot of people like the cover-up method, and they just like to stick with that. But again, I can still write out my steps. I can still do the cover-up over here and write, you know, negative 3x equals negative 18 if I need to, you know, up here and solve it out that way, but without having to actually write the 0, that's fine as well. Eight, 2x plus y equals 10. All right, so I'm going to find the x-intercept, so I'm going to cover up y. So I have 2x equals 10. So what is x equal to? 5. I don't do the raising hand thing. You just say the answer. All right, to find the y-intercept, cover x up, and I have y equals 10. Look at that. I don't even have to do anything on that one. Literally just write y equals 10. And those are your intercepts. Now, sometimes what happens is you get a problem in a different form. Y equals 2x plus 24. And so before I use my cover-up method, I need to move all the variables to the left side. I need it written in standard form. So I'm going to subtract 2x from both sides so that I end up with negative 2x plus y equals 24. And then now I can do the same thing that I was doing otherwise. So if I want the x-intercept, cover up y. I have negative 2x equals 24. So what is x?
12.
Negative 12. X equals negative 12. Find the y-intercept, cover up x. I have y equals 24. Obviously don't have to do anything on that one other than just copy it down. So that's your two intercepts on that one. So you just need to make sure that you move all the variables to one side first before you do this one. All right, how do we feel about that?
Pretty good.
All right, so now let's get into the ones where we're graphing these ones. So if you want graph paper, you can use graph paper. If you don't, that's fine. I'm not going to put the little graph up here today. Well, I'll put it up here. Whoa, not that button. All right, so these ones we are now graphing, but I'm going to find the intercepts first because it's going to make our graphing way easier. Let me turn this down so you can actually see the lines. A little bit more. All right, so number 16, y equals x plus 3. So yesterday what we were doing is we were plugging in values of x and finding the y values, and then we were plotting the points that way. Today we're doing it a little bit different when we graph these ones. Yesterday I told you have to plot how many points on a graph? 3. In this section, you only need 2 points on the graph. Okay? You're going to have an x point and a y point, and that's it. Okay? So first thing I need to do is move this x over here. So I'm going to have negative x plus y equals 3. And then I'm going to find my two intercepts again. So when I find the x-intercept, I'm covering up y. I have negative x equals 3. So what does x equal to?
-3.
So x equals negative 3. And then I'm going to cover up x to find y. I have y equals 3. Obviously, that one just stays that way. And then I'm going to set up my graph here for this one. Make this really large for no reason. So we literally just go on the x-axis and we put a dot on negative 3 on the x-axis. This point, the intercept, is technically negative 3, 0, and the y-coordinate is technically 0, 3. So then on the y-axis at 3, I put a point, and then I connect the dots. Yes.
How do you get negative 3 for x?
Because I have negative x equals 3, so I divide it by negative 1.
Oh.
So x equals negative 3.
So if it's like a negative x, we just put the sign on the number.
This is usually everybody's favorite graphing method because it's easy. It's just putting 2 points on the graph. 20. Y equals negative 2 plus 8x. What do I need to do first? Subtract 8x. So I've got negative 8x plus y equals negative 2. So find the x-intercept, cover up y. I have negative 8x equals negative 2. So what is x?
4.
Because I've got negative, look, I've got negative 8x equals negative 2. Divide by negative 8.
Oh.
So x equals 1 over 4.
What?
Negative 2 divided by negative 8 would be a positive 1 over 4. 2 goes into 8 4 times.
So we're gonna have to find a fourth one.
It's not hard to do. Plotting 1 point. And then over here, cover up x. So y is equal to negative 2. So set up your graph. So at x is equal to 1/4. That means just a quarter of the way. Doesn't have to be perfect. I put a dot. And then on y at negative 2, I put a dot. And then I just connect them. What? Okay. Well, that did not.
Kind of be like
Close enough. Pretty easy, right?
So basically you just get x and y on the same side
Mm-hmm.
and then divide.
Yep.
Then plot.
Yep.
That's pretty easy.
See, 24. 8x minus 5y equals 80. All right, this one's already on that side, so I'm going to cover up y to find my x-intercept. I have 8x is equal to 80, so what is x? X is equal to 10. Over here, cover up x. I have negative 5y equals 80.
Negative 16.
So y equals negative 16. Now, those are pretty big numbers. So I'm going to use this opportunity to count by 2s and show you what that would look like on the graph because we've been mostly counting by 1s. So y is going to be going down pretty far. So I'm going to do this, actually. All right. So I'm going to count by 2s. So I'm going to label my graph. Now, you don't have to put all of them on there as long as you put at least one showing that you're counting by 2s. And then down here, negative 2, negative 4, negative 6, so on and so forth. I didn't make my graph big enough. So all the way down to negative 16 there, I counted by 2s. I'm just going to put these on there. I don't really need them. I'm only working on this part of the graph, so I'm not worried about the other ones. So at x equals 10, I'm going to put a thing. Dot here, I counted by 2s, so that's right there. On the y, I also counted by 2s. I'm going down to negative 16, so I'm all the way down here. Make sure I counted right. 8, 10, 12, 14, 16. And then connect the dots. So my graph doesn't have to be excessively large because I just chose to count by a different set of numbers. So if you count by something other than 1s, you've got to make sure you label it. Yeah. Some of the questions tell you to draw a line that has the given intercept, so they'll just tell you what the x and y intercept is. That means you literally just put those 2 points on the graph and connect the dots. I feel like that's pretty simple. I don't really feel like I need to do one of those. On a graph, if they give you, say if they gave you the graph and not the equation and they asked you for the intercepts, then you would just look at this and figure out what the x-intercept is and then the y-intercept and put that down. So, any questions on this? We feel okay with it? Feel ready to start some problems? Okay, cool. All right, problems. Let's go with 5 through 35, every other odd. And if it doesn't end on 35, like if it ends on 33, then obviously don't worry about 35. I haven't counted, so that may or may not end correctly, but anyways.
Stacy, isn't it homework like?
Huh?